My performance assessment is to complete the following questions. Using a sample general aviation 4-passenger pilot operating handbook, compute the weight and balance of a sample load of 1 pilot and 1 passenger with full fuel at 5,000 foot density altitude, and also from the pilot operating handbook to compute if this aircraft can safely take off within CG using a 2,500 foot runway. So the airplane that we are using is a 1978 Cessna 182 Quebec. We have a sample loading problem of a weight and balance table from the pilot operating handbook. And so to complete that, we're gonna take, it gives us our empty weight of 1,800 and our moment of 63.3. Now the problem tells us full fuel, so we're gonna use standard takes at 88 gallons. And gas is 6 pounds per gallon, so we're gonna do 88 times 6, and that gives us a weight of 528. To get the arm for the tanks, we can divide the sample airplane. We can divide the moment by the weight to get the arm that it's at. So we're gonna take 18,100 and divide it by the weight of 390. And we get an arm of 46.41. So that's what we multiply the weight by the arm to get the moment. So 528 times 46.41 is equal to, it's 24,504, but because this is in thousands, we're gonna put 24.5. We're gonna use standard weight for the pilot and the front passenger of 170, so that's 340 pounds total. And it's adjustable seats from 32 to 50. We're gonna say they're around the middle, which is at positive 41. So we multiply 340 times 41, and we get 13,940. And so that in thousands is 13.94. And we have no other passengers and no other baggage. This chart also gives us a allowance for engine start, taxi, and run up, saying that we're gonna burn that off before we take off. It gives us 10 pounds to burn, but we're gonna be conservative and say we're only gonna burn 6 pounds of fuel, which is about 1 gallon of gas. So we're gonna put negative 6 pounds of fuel, and multiply that by the arm. So 6 times 46.41, the arms of the tank, and we get 0.28. And that's a negative number because we're taking that out from our moment because we're burning that fuel off. So to get the takeoff weight and moment, we're gonna add these columns up. So we're gonna get 1,800 plus 528 plus 340. And then we're gonna subtract our 6 pounds of fuel. And that gives us a total weight of 2,662. And add up our moments, 63.3 plus 24.5 plus 13.94. And we're gonna subtract our moment of 0.28. And we're gonna get our moment at 101.46. Using this graph from the pilot operating handbook, our center of gravity moment envelope, this is going to tell us whether or not we can take off within CG. So we have our moment of 101.4, that's right here, and our weight of 2,662, that's around 2,700. If we bring these two together, we are well within the envelope, so we can safely take off. All right, for the second part, we had to make some assumptions about our problem. It gives us 5,000 foot density altitude, and the table we are given uses pressure, altitude, and temperature. So we're going to back into it using the density altitude equation, which is density altitude is equal to pressure altitude plus 120 times the difference of outside air temperature and ISA, which is International Standard Atmosphere. And so to get a density altitude of 5,000, we're going to take our pressure altitude of 4,400, and we're going to say our outside air temperature is 10 degrees Celsius, and at around 4,400 feet, our ISA is around 5 degrees Celsius, so we're going to subtract that from our outside air temperature, and when we simplify this, we get 5,000. So using the table of our pressure, altitude, and our temperature, we're going to go here, we're going to round up to 5,000 foot pressure, altitude, and 10 degrees Celsius, and we're going to see our ground roll for that takeoff is 865, which is well within bounds.